Alrighty, section 5.5, dividing polynomials. So we're coming to a close on our operations on polynomials. We've done addition, subtraction, we've composed functions in polynomials, we've multiplied in the last section, so now we're going to divide, and that'll be our 5 basic operations of polynomials. We're actually going to divide this last one up into 2 different sections. Today we're going to talk about it using long division. Long division. That does not mean this process is going to be long. That means it's going to be the same long division that you used when you were back in like 3rd grade, right? And you were dividing numbers using long division. So that's the same idea. Before we get there though, we're going to take a little trick. We're going to remind ourselves, we're going to divide some scalars and monomials. Now if you remember from the last couple sections, scalar is just a number, right? So a 3, a 2, a 5, something like that. And a monomial is just one term. So like 3x squared or 4x or heck 6 is a monomial. But we would call that a scalar as well. So we're going to divide by one of those. And we're going to use that, a nice shortcut, something we already know about. We're going to use the quotient rule. Quotient rule from way back when in section 5.1. Basically just a little reminder, it said if you have something like p to the 4th over p squared, well then you've got some multiples going on here. You can cancel 2 on the bottom with 2 on the top, and you're just left with a p squared, right? So then we're going to use that rule, and it says it works if the bottom is bigger too, right? So it's okay if the bottom is bigger, because you'll just end up with a fraction, right? But basically the idea is you can cancel this stuff out. We're going to use that rule to solve stuff like this. So we have 15x squared minus 12x plus 6, this nice trinomial, all being divided by 3. Remember, that's what a fraction means, something the top divided by the bottom. In order to do this, I'm going to split up this trinomial into 3 separate fractions, each monomial being divided by 3. So let's go ahead and do that. Let's rewrite this as 15x squared divided by 3, minus 12x divided by 3, plus 6 divided by 3. And you're more than welcome to call this plus 12x, plus negative 12x, right? If you want to put the negative on the 12, or if you want to just keep it as the part in between the terms, either one's fine. You'll end up with the same result. So now that I've got 3 separate division problems, I can use quotient rule 3 separate times. So let's just use quotient rule. Well, I have no x's to cancel, right? I don't have anything x-wise that I'm dividing by, but I know that this 15 and the 3 will cancel to give me 15 divided by 3, or 5. So I end up with my first term being 5x squared. Second one, I've got 12 canceling with 3, which gives me a 4. So I've got minus 4x. And then the last one, the 6 and the 3 cancel to give me a 2. Plus 2. And now I have successfully divided this trinomial into 5x squared minus 4x plus 2. Fantastic. Alrighty, let's do the same exact process for a monomial. So remember, that was a scalar, that was just dividing by a number, where now we're going to divide by a monomial, something that actually has an exponent in it. And it looks, well, let's just do the same process though. So let's try this out. I'm going to take each one of these parts of the trinomial, and I'm going to divide it up into 3 separate fractions. This actually works whether you're working with trinomials, binomials, anything bigger, polynomials. It works with a monomial, but that's just plain quotient rule, right? That's just plain quotient rule. But this process only works if you're dividing by a scalar or a monomial. If you're dividing by a scalar or monomial, you can divide anything you want, right? And it works this way. So let's try splitting it up. We've got 5m cubed divided by m squared, 5m squared. We've got plus negative 9m squared divided by 5m squared. And lastly, we've got 10m divided by 5m squared. All right, so let's handle each one of these individually. 5 over 5, those are going to cancel, right? So they just go away altogether. I get a 1. If I've got 3 m's on the top and 2 on the bottom, 2 of them are going to cancel, and I'm left with just m. Sweet. Over here, negative 9 and 5, unfortunately, are what we call relatively prime. They do not divide in any way. I can't reduce them or anything like that. So that's just going to stay a negative 9 over 5. But then I've got m squared over m squared, and that cancels out. So I just left with negative 9 over 5. Over here, I've got 10 and 5, so 10 divided by 5 would be 2. And then I've got to be careful because I do have some m's that are going to cancel, but so I've got one m on the top canceling with one of the two m's on the bottom, but that leaves me one m on the bottom, right? So it leaves me an m here. So what that leaves me is a plus 2 over m, and that happens sometimes. And now we've resulted in our polynomial. M minus 9 over 5 plus 2 over m. And you might be thinking, wow, that's a weird polynomial. It's an uncommon polynomial, I will give you that, but if you think about it, it's still written in the correct order. We've got m to the first, then we've got an invisible m to the 0, and then if you think about what a fraction is, that says 2m to the negative 1. So we've got 1, 0, negative 1. It's still in descending power. That's just a little fun fact, that it is in the right order, even though it looks a little uncommon, right? It looks a little strange. Okay, so that's division by a scalar and a monomial. You essentially just break it up and divide using the quotient rule in each case. Now, unfortunately, when we're presented with stuff like this, I'm going to scroll all the way down to example 2.1 on the next page. When you have stuff like this, this rule no longer applies. Quotient rule only works if you're talking about term to term, right? So we're talking about one term being divided by one term, and whether that's a scalar or monomial, that's fine, but it's only one thing. As soon as you throw in two terms, like m minus 2, remember that minus part makes this a binomial, this separating out method no longer works, because you'd have to separate out in weird ways, and you would miss stuff and it wouldn't work. So what we're going to do is we're going to take a pause, we're going to go back to third grade. We are going to divide 240, well, so here they divided 249 by 3. We're going to do a different one. We're going to divide, let's see, let's do 360, no, let's not do 360. I'm trying to think of a number that goes evenly into 3. 912. We'll do 912 by 3. So 912 by 3. Let's divide 912 by 3. So let's start by, let's remember all the way back to third grade. How does one start a long division? Well, you set it up in this kind of format, right? You put what you're dividing by on the outside. You put what you're dividing on the inside. And we'll talk about this again later. This is called the dividend. And this is called the divisor. You don't really need to know at this point, but that's pretty much what they are, the dividend and the divisor. And let's start long dividing. So how many times does 3 go into 9? Well, 3 goes into 9 3 times, right? It goes in 3 times, and I'll write that right above the 9. 3 times 9, so I'm going to multiply 3 times 9 to get 9, and I'll subtract the 2. I get 0, right? I get 0 there. Now I'll bring down the 1 and write it next to the 0. Let's line this up a little better. So I'll get 0, and I bring down the 1. Repeat the process. How many times does 3 go into 1? Well, it doesn't. It doesn't go in at all, so we'll call it a 0. 3 times 0 is 0. Subtract, I get 1. And now I'll bring down the 12, right? So it's a process of how many times does it go in? Okay, that's how many times. Multiply it by 3, subtract it out. How many times does 3 go into 12? Goes in 4 times. 3 times 4 is 12. I subtract, I end up with 0 again, but this time there's no more to bring down, and so I'm done. And this little guy here is called my remainder. My remainder. The answer I got is called my quotient, hence the quotient rule. That one you already know. The quotient, and that's how we long divide, right? So remembering way back when to long division. Alrighty, any questions about that? Make sure you pause, because we're now going to do it with variables, and I want to make sure it makes perfect sense. Alrighty. So we're going to use the same idea to divide this trinomial by this binomial. Since it's a binomial, we can't just use the exponent quotient rule. We're going to have to use long division. So I'm going to take this divisor, m minus 2. He's going to go on the outside. And I'm going to take this dividend, I'll put it in orange. He's going to go on the inside. So 2m squared plus m minus 10. Plus m minus 10, right? Okay, good. And now I'm going to long divide. I'm going to long divide these two polynomials. When I'm long dividing, I just want to really consider, when I'm thinking about that part where how many times does 3 go into 9, I want to look at the m. How many times does m go into 2m squared? In other words, what do I need to multiply m by in order to get a 2m squared? Let's think about that over here. So I have this m, I need to multiply something, and I need to get a 2m squared. Well, it looks like I'm going to need another m, right, to get m squared, and I'm going to need a 2. So 2m goes into 2m squared m times, if you want to think about it that way. In other words, I need a 2m times an m to get a 2m squared. So that was the step where we found out how many times 3 goes into 9, how many times does m go into 2m squared. Cool. Alright, so now we'll do that part where we multiply 3, it went in 3 times, so we'll multiply 3 times 3 to get 9, right? We're going to do that part. So 2 times m is going to give me 2m squared, just like we talked about. But I'm also going to distribute it to the 2 part. That's how I get this next part to work with. So I'm going to do 2m times 2, negative 2, I get minus 4m. Minus 4m. Awesome. And then just like our last step, when we subtracted 9 minus 9, right, to get 0, we will subtract both of these. Subtract both of these. Notice I put a subtraction sign in parentheses around it to remind myself that I'm subtracting the entire binomial. The entire binomial I'm subtracting here. I'll do it term by term though. 2m squared minus 2m squared, those cancel. I'm left with 0m squared. M minus negative 4m is the same thing as m plus 4m, so 5m. I'm left with positive 5m. Sweet. Now I will bring down the next term. The next term was negative 10. We already used this m part, so we're just going to minus 10 all the way down. Alright, let's do it. Just do one more round. So I can kind of ignore this part because that just goes away. 5m. How can I get an m to a 5m? Well, I'm going to need the 5 part, right? Just like in the last one, I needed another m and an m. I need an m to go to 5m, so I'm going to need to times it by 5. So I'm going to need to times it by 5. I know I'm bleeding into the problem here, I do apologize. But that's how I'm going to get an m to a 5m. So now I'll go ahead and multiply. I did the what goes into it step. Now I'm going to do the multiply step. So 5 times m is 5m. 5 times negative 2, so I'm multiplying both of these guys, right? I get negative 10, and that's the multiplication step. The last step, just like we did last time, I will subtract. I'm going to subtract both these guys. I take 5m minus 5m, get a 0. Negative 10 minus a negative 10, which is negative 10 plus 10, is also a 0. It looks like in this case, my remainder is also 0. And I figured out how to divide it. My answer, my quotient, is going to be 2m plus 5. Alright, so it's the same steps as long division. It's how many times, what goes in, we should call it what goes in. What goes into m, right, to multiply, and 3 subtract. Now something I see a lot happening is people like to add in step 3. People always like to add in step 3, I don't know why. Make sure you do not add. It is find out what you need to multiply by it, and then subtract it out. So, because if we had added here, we would have gotten negative 3, right? And we didn't want negative 3, we wanted positive 5, right? That's what we wanted. So, cool. That's how you divide a polynomial by a binomial. Let's try it again. Let's try it again. So we've got this trinomial up top. That will be what goes underneath. I'm going to kind of section off this so that we know we're dealing with another problem. Okay, cool. So I've got this trinomial of 12m squared minus 11m plus 5, minus 5, minus 5. I don't want to write that close because I know I'm supposed to write my answer up top there, so just kidding. We're going to move it down a little bit. 12m squared minus 11m minus 5. That's our dividend, what's being divided. What we're dividing by is our divisor of 4m minus 5. 4m minus 5. All right. Now, when we're thinking about what goes in, what goes into m, we need to think only about this first part of the binomial here. What do I need to multiply by so that 4m becomes 12m squared? Well, let's take a look at it. So 4m times something is going to equal 12m squared. I can maybe divide that, 12m squared by 4m. Divide that, I get a 3. Divide that, I get an m. So it looks like I need a 3m. So 3m, and I'm going to put it over the m's. 3m. Awesome. All right, so now I'll make sure I'll multiply it out. That's my next part. I'm going to multiply these two guys. I'm going to distribute it out. 3m times 4m. Well, we chose 3m because we know it ends up being 12m squared. 3m times negative 5 is going to be negative 15m. Negative 15m. So we choose what we need to multiply by, then we multiply, last we subtract. So we'll subtract these. I'm going to put some parentheses around it. 12m minus 12m, it's going to equal 0. So I don't really need to write it, but it's going to equal 0. They're going to cancel out. Right? And I have to be careful now. Negative 11m minus negative 15m, or negative 11m plus 15m, is going to be a positive 4m. 4m. Positive 4m. All right. Positive 4m. And then I'm going to drag and drop this negative 5 down. All right. So now I will do it again, right? So I now need to find out how to get a 4m to a 4m. Well, it's already a 4m, but I have to multiply by something. So what can I multiply by that won't change anything? That's right, I can multiply by a positive 1. So a positive 1. Very nice. Multiply by positive 1. We end up getting 4m. And 1 times negative 5 is minus 5. And if we subtract those two, clearly we end up with a 0. And so our quotient is 3m plus 1. Alright, so we're going to try this next problem now. But before we do, I'm going to let you try it on your own. But before we do, notice there's a cube there, right, instead of a square. One teeny thing you need to kind of make an alternation for. When we were multiplying, alternation's not a word, alteration for, thank you, is when we're multiplying, that didn't matter. It didn't matter if it was an x cubed or an x squared or if something was missing, right? But since we're working with long division, we have to have every single exponent represented. So what we're going to do is we're going to change this guy to 3x cubed plus 0x squared plus 2x plus 5. That way we've got every single power represented all the way down to 0. That will be important in this process. So make sure you make that change and then go ahead and try this problem on your own. Alright, I hope you had time to try the problem. We are going to do the example right over here. So I'm going to kind of draw myself a little thing here. So now my dividend is 3x cubed plus 0x squared plus 2x plus 5, right? And yeah, it's got 4, but that's okay. The process doesn't really matter how many terms you have, just as long as you've got every single one of those exponents. And I'm going to be dividing by x plus 3. All right, how do I get an x to a 3x cubed? Well, I'm going to need a 3, right? And I'm going to need 2 more x's. I'm going to need x and x plus the x I already have gives me an x squared. So 3x squared times x will give me 3x cubed. Now I'll go ahead and multiply that out. 3x squared times x, we just talked about that, 3x cubed. 3x squared minus, or times negative 3, it's going to be negative 9x squared. All right. Now I will make sure to subtract not add, I'm going to subtract. So 3x squared minus 3x, or sorry, 3x cubed minus 3x cubed is going to give me 0. They're just going to go away. 0 minus negative 9 is going to give me a positive 9x squared. All right, now I'll go drag the next one down. So plus 2x, right? I already used the 0x when I subtracted, so plus 2x. And I'll repeat the process. So what will multiply by x to give me 9x squared? I'm going to need a 9x, right? I already have one of the x's. I'm going to need another one. And I'm also going to need that coefficient of 9. Now multiply 9x squared, or 9x times 9x times x. Going to be that 9x squared plus, oh, nope, in this case minus, 9x squared times negative 3 is negative 27x. And now I will subtract that. Okay, 9x squared minus 9x squared, big fat 0. They cancel each other out, that's why I chose it in the first place. 2 minus negative 27 is 2 plus 27. I make a mistake. Oh, maybe not. Okay, 9 plus 27 would be 29x plus 5. 29x plus 5. Let me rewrite that 9 real fast. 29x, and then I'm going to drag down that 5 if you're wondering where that 5 came from. Plus 5. Okay. Last round, how do I get an x to a 29x? I'm going to have to add 29. Multiply by 29, I end up getting 29x minus 29 times 3 is 87, negative 87. And then I will subtract. Well, I subtract to get 0 here, but this is a little different. 5 minus 87 is going to be negative 82. Negative 82. Suddenly my remainder is no longer 0. Well, this is still my quotient, and that's awesome, right? But over here on the end, I'm just going to tack on, to my answer a plus that negative 82 over my divisor. If you remember that from way back when, that's how you'd write a remainder. Negative 82 divided by x minus 3. That's the remainder. And now we have our quotient. Alrighty. So the remainder over the divisor is what you tack on to the end, and that part should never be left off. Never be left off. It's not always going to work out equal to 0, right? We've seen many instances of numbers where they divide and they don't end up being 0, right? So 6 divided by, that's a horrible example because 6 goes into everything. 6 divided by 5. That's not a whole number, right? It ends up being 6 divided by 5 goes in once with a remainder of 1, right? And if we were, doing real numbers, it'd be about 1.2, I believe. Yeah, 1.2. We're not going to get into there's no decimal version of a polynomial, so we're just going to have to talk about the remainders. So remainder of 1. Happens a lot. Let's try another one that's a little bit longer. But this one has all of the numbers represented. So let's try dividing it using long division. Now I think I'll write it here. So our dividend, our thing we're dividing, is going to be 6r to the 4th plus 9r cubed plus 2r squared minus 8r plus 7. And I do a little mental check. 4, 3, 2, 1, 0. Okay, I'm not missing any powers. Now look at my divisor. My divisor is missing a power. What power is it missing? That's right, it's missing the r. So I'll make that adjustment here. 3r squared plus 0r minus 2. So now I'm dividing by a trinomial. But again, the process is exactly the same. Okay, so how am I going to get a 3r squared to multiply to a 6r to the 4th? Well, I'm going to need, how do I get 3 to 6? I'm going to need a 2. I'll do this in blue. I'm going to need a 2. How do I get an r squared to an r to the 4th? I need another 2r's, an r squared. So let's multiply by that. 2r squared times 3r squared, that gives us our 6r to the 4th. 2r squared times 0r is going to give us 0r cubed. 2r squared times negative 2 is going to be a negative 4r squared. So because I had 3 terms in my divisor this time, I have to multiply that blue 2r squared into all 3 of them. No big deal though, right? Just multiplication, term by term. Now I will subtract. Got to make sure I subtract everything. 6r squared minus 6r squared, that's 0. So it goes, doesn't really do much, just goes away. 9r cubed minus 0r cubed is going to be 9r cubed. That was a horrible r. Let's draw that again. R cubed. And then 2r squared minus negative 4r squared is not going to be negative 2r squared. It's going to be plus 6, right? Because we have a minus a negative. So plus 6r squared. All right, now we will drag down our negative 8, r, and we're ready to start round 2, right? So now we'll do it all again over with 9r squared, 9r cubed. Okay, how am I going to get a 3r squared to a 9r cubed, right? I'm only dealing with this guy. So that to that is going to need a 3 and one more r to get r squared to r cubed. So I'm going to multiply by 3r. 3r times 3r squared, but we just talked about that. That's 9r cubed, right? If that doesn't happen, you probably chose the wrong thing. The whole point is to get those two to cancel each other out. 3r times 0r is going to be plus 0r cubed. 3r times negative 2, negative 6r. Then we subtract them, right? So we end up with, so subtract, the 9's cancel each other out. 6 minus 0, oops, I'm so sorry, this should have been a squared, not a cubed. Okay, so a squared. Subtract them. We end up getting 6 minus 0 would give us 6r squared. 8r minus 6r gives us a minus 6r, right? Would be plus 6, so negative 2r. And then we drag the 7 down. Plus 7. And we're ready to start our last round of this. Excuse me. Alrighty, so how do you get a 3r squared to a 6r squared? You just need to multiply it by 2, right? It's already got enough r's. 2r squared, but I need the 3 to go to a 6, so I multiply it by 2. Go ahead and multiply that out. You get 6r squared. 2 times 0r is going to be plus 0r. 2 times negative 2 is going to be a negative 4. And we will subtract. The 6's go away. Negative 2 minus 0. I should probably write subtract, so remember we're subtracting. That's just going to be a negative 2r. 7 minus negative 4 is going to be a positive 11. Alrighty, again, this time we ended up with a remainder. So I'll go ahead and write that remainder on the end. I'll write the remainder over the divisor. And our divisor was this guy. I don't need to put the 0r in the divisor, but just for consistency's sake, since I already changed it, I'm going to go ahead and do that. Minus 2. Alright. And we have our quotient with the remainder over the divisor. Ah, I erased my 2. Okay. And there is our solution. Go ahead and try out this last problem on your own. Watch out for things like missing zero or missing exponents. Watch out for things like remainders. Make sure you're subtracting. Give it a good, nice college try. And then we'll come back in a second. We'll do it all together. Alrighty, so I hope you gave yourself plenty of time to try this. If you didn't stop the video or you need more time, please make sure you do so and actually give these ones a try, because these ones can be kind of complicated because you're dealing with so much at one time. But hopefully you gave it a try. I'm going to go ahead and section off just this part here so that we can know which problem we're on. Taking a look at this, it doesn't look like I have any missing powers, right? In the dividend, I've got cubed, squared, single, nothing. And then in the divisor, I've got single and then nothing, so I'm good there. Let's try dividing it. 2p plus 2 goes into 2p cubed plus 5p squared plus p minus 2. All right. I'm going to erase this little part right here and draw a new one. Okay, cool. Alrighty, so we'll go piece by piece. So how do I get a 2p to a 2p cubed? Well, I don't need the 2 part, but I will need the p squared. I need 2 more p's, so p squared. P squared times 2p, we just talked about it, p squared cubed, or p cubed, right? 2p cubed. P squared times 2 plus 2p squared. Now I'll subtract that. These two guys end up canceling out. 5p squared minus 2p squared gives me 3p squared. Drag and drop the p. Alright. Round 1, done. Round 2 is going to be, how do I get a 2p to a 3p squared? And this probably is where a bunch of you got stuck. I know I need another p. It's got to be a p, right? But how do you get a 2 to a 3? Let's think about this over here. 2 times something is equal to 3. In other words, 2 times x is equal to 3, right? I know 2 times something, we'll call it x, is equal to 3. How would I solve this equation? That's right, I divide by 2 to both sides. So it looks like x is equal to 3 halves. 3 halves is what I need to multiply 2 by to get a 3. And I can double check that. 2 times 3 halves, cancel, cancel, I end up getting a 3. So this is going to be a plus 3 halves p. And yes, that does happen. Sometimes that does happen. I'm going to write it a little bit clearer. 3 halves p. Now let's multiply. 3 halves times 2, we know that that's just 3p squared. 3 halves p times 2 is just going to be a 3p. And then we'll subtract. I'm running out of room here, but that's good. So 3p squared minus 3p squared, those cancel out. P minus 3p is going to be a negative 2p. And then I'm going to drag and drop this other negative 2 down. Last but not least, how do I get a 2p to a negative 2p? I multiply by negative 1. Multiply both of those, you get negative 2p and minus 2. So a remainder of 0, and there is our quotient. Excuse me, I'm so sorry. The problem with this one was this fraction right here. Sometimes you end up with fractions. Sometimes that does happen, but you should never let it discourage you from the problem. It doesn't mean there is no quotient. It just means you have to use a fraction, and that's it. So just so you can see it a little clearer, our quotient was p squared. I love when I say clearer and then I can't write it. P squared plus 3 halves p minus 1 was our quotient with no remainder. Fabulous. Alright, the last thing we're going to talk about today is dividing polynomial functions, which, remember, functions are just fancy polynomials, so really you don't see a lot. There is one thing we have to talk about, though. First off, this is what they look like. We're going to erase this stuff here. So when you see it, up until now we've talked about adding functions, subtracting functions, composite functions, and multiplying functions. Now we're dividing them. So you will see it often written as this, f over g of x, and it just means take f of x and divide it by g of x. Just like composite, this one matters about the order, right? G times f is going to be the same thing as f times g. But when you divide f by g, it's going to be different when you divide g by f, right? So whichever one's your divisor needs to be on the bottom. speaking of that, your divisor has to be on the bottom of a fraction, right? So your divisor cannot equal 0. Your divisor cannot be the constant function x equals 0, and it also cannot be any of the places where x is equal to 0. So we'll have to watch out for that. The domain of this function cannot have any x's equal to 0. So basically, because why not? Why couldn't you have 0 on the bottom there? That's right, because you can't divide by 0. That doesn't make any sense. Since you can't divide by 0, you cannot have your function that you're trying to divide by equal 0. Just like if you had y equals 5 over x minus 1, you can't say that x equals 1, right? Because if x equals 1, you suddenly got 5 over 0, and it's a nightmare and everybody pulls their hair out. So we don't want to do that, right? We want to make sure it's not equal to 1. Now, unless you're specifically told g of x is equal to 0, you don't need to mention that. That's okay. You can maybe leave it off to the side. G of x does not equal 0. Right, for where g of x does not equal 0. I keep writing over instructions today, sorry. G of x does not equal 0. And that's pretty much all you have to do with that. So as long as you make sure you make that point, you really don't, it doesn't change anything about the problem. Let's go ahead and try this problem out then. Now that we've said that g of x cannot be 0, right, because we're trying to find f over g, f divided by g. And we're going to do this the same way we've been doing any other function problem. We're going to plug in what we know to f and to g. So we have f divided by g of x is equal to f of x over g of x. And therefore, since f of x is equal to this trinomial, 2x squared plus 17x plus 30, 2x squared plus 17x plus 30, whoops, over, see, g of x is 2x plus 5. We now have a division problem we've seen before, right? So this looks very much like what we were doing up here. Sweet. So let's go ahead and actually divide those now. We've got a power of 2, a power of 1, a power of 0, and then in our divisor we have a power of 1 and a power of 0, so it looks like we're not missing anything. Don't need to change it, so we have 2x plus 5 divided by 2x squared, I'm sorry, dividing, not divided by, 17x plus 30. Alright, and then we'll finish out that, and we'll start dividing. Cool. 2 goes into 2x, x times, multiplied by x, you get 2x squared plus 5x. 2x squared plus 5x. Subtract those two. Let me write that a little bit more lined up. Okay. Subtract those. You end up with 0. 17 minus 5 is going to be a 12x plus 30 when you drag the 30 down. Okay, round 2. How do I get a 2x to a 12x? I have to multiply by 6. 6 times 2x is 12x. 6 times 5 is 30. Oh no, hey, look at that. It looks like there is no remainder, which is fabulous. So f over g of x is equal to x plus 6. Even if there was a remainder, we would just tack it on the end, right? So that's the reason we start doing this thing, is when we have a function, we want to still plug into it later, we need to make sure that remainder is accounted for. So that's why we tack it on the end. Here, we did not need to do that, which is great. The last part of the problem, we'll do the same sort of thing we've been doing everywhere else. Remember, with functions, what's great about them is they're not expressions, they're equations. So we can actually write, or we can actually compute some of these problems. So we can actually plug in numbers. So f minus g, let's do it up here. F minus g of -1, remember what that's asking is, now that you have this function, what is it evaluated at -1? What is f over g when x is -1? So we get -1 plus 6 or 5. F of -1 is equal to 5. Alright, so that's dealing with division of functions, right? It's not super complicated. It falls very nicely with the other operations on functions. Just a reminder, that's addition, subtraction, composite, multiplication, and now division. We have all of those. We are going to talk about a different form of division next time. You may know it's called synthetic division, but right now you're going to have to work with long division, okay? If you have any questions at all about maybe about the fraction part or what to do with the remainder or some missing powers, any of that jazz, make sure you get your questions answered before you leave today.